Hey everyone, so we are going to be talking about metallic bond. This is when two metals are going to share electrons. So let's do a quick recap. Right now, we have learned that ionic bonds is a metal and a nonmetal, and one's going to lose, one's going to gain. Okay. We have covalent bonding, which is where they share. They're the nice bonds. These are two non-metals. So now we're going to talk about metallic bonding. All right, so metallic has the word metal in it. So very easy to remember that these are two metals and they share. All right, so I'm going to kind of go through the notes. We have two metals, and basically what this looks like is it looks like a sea of just electrons that are constantly moving. I'm going to give you an image in the next slide that's going to show this. So I'm not going to go super in depth of this right now, but we do need to know that what it looks like is it's a sea of electrons and the electrons are moving. We're going to talk about how two metals share, and two metals are going to combine and they're sharing their outside valence electrons in order for them to have those full valence electrons. We want them to be at 8. Remember, 8 is that number that we want them to get to have that full outer ring. So, talking about some properties of metals. So, I want to kind of recap from about a few weeks ago when we were talking about how metallic bonds allow metals to conduct electrical currents. So, they are very good conductors. When I turn on a lamp, electrons move within copper wire that basically allows the lamp to have a current go through to that outlet in the wall. Electrons that move, that is going to be your valence electrons in those copper atoms. And as a kind of a reminder, electrons are moving freely because there's no electrons that are connected to one atom. So they're able to basically just be really good conductors, and they have that electrical current going through. Now, another thing that's really interesting about a property of a metal is that we can reshape metals. So it's very easy for us to have like a particular type of metal, and we can roll it, hammer it, pound it, and it can basically be reshaped. So a lot of times, certain types of metals will get reshaped for other purposes. Like for example, aluminum can be pounded into thin sheets, which then can be made into aluminum foil. So some of you guys might be celebrating various different holidays in the upcoming months, and maybe you are having family gatherings and you might be wrapping up your food in aluminum foil. And so just think about how some metals can be very thin sheets as well, and being used for daily use. Another thing that's really interesting about a property of a metal is that ductility, which is basically when you can have metals drawn to wires. So all of this is basically going back to my main message is that metals are very good conductors. Now, if we talk about the periodic table and we're talking about metals being on what side, are we talking about the left? Is it the zigzag, the staircase, or the right side? Metals are on the left side of the periodic table. So I want to show you an example of what the sea of electrons basically is. So we have Zn. We're talking about this element, right? That's symbol. And you will see that the electrons are constantly just in motion. And that is basically the visual that I can give you. With that being said, metallic bonds are two, Metallic bonds are two metals, and they are sharing. So I just want to emphasize this again one more time, that when we're talking metallic bonds, we are talking about two metals that are going to share those electrons. So you will see them here. They're basically, we got zinc, and they're sharing their two electrons. So just want to reemphasize, if you have any other further questions about covalent, metallic, or ionic, there are additional videos, or we are available during lunch. So please keep studying, and I'm going to have you guys transition to our gizmos, which is going to be on Explore Learning. So I will get you guys set up on that. Thank you so much and have an